Now we are going to start with the chemical properties of alkanes. As you all know that in alkanes there is a single bond between carbon and carbon. So what kind of chemical reaction do you think they can undergo? Like, can they undergo addition reaction or can they undergo a substitution reaction? So it is clear because they don't have any extra bond, so there is no point of undergoing or no point of talking about the addition reaction because they do not have any extra bond, so they cannot add up anything, right? But they can undergo substitution reaction because they have got the H atoms and which they can easily replace by the incoming group, and they can show a substitution reaction. So see how they show a substitution reaction. And you know that see, alkanes are called as paraffins. That means they have low affinity, but still they show a certain substitution reaction, and there is a reaction, you can say a kind of substitution reaction which occur in presence of sunlight. And what is that reaction? Obviously it belongs to a category of substitution, but what is that? It is chlorination of methane. In chlorination of methane, you know that in methane chlorine is added, and the most important property of this reaction is that this reaction occur in presence of sunlight. So just look at the board, what products are formed. So here we have methane. I am just adding chlorine to it. So as it contains the replaceable H atom, that means the Cl is going to replace H, but it is just going to occur step by step, right? So what it is going to form? It is going to form CH3Cl, and along with that we have HCl. So the reaction doesn't stop here because still it has the 3 replaceable hydrogens. So again it reacts with chlorine and 1 hydrogen again gets replaced, and now it becomes CH2Cl2 plus HCl. Right. So do you think the reaction stops here? No, it doesn't stop here because again it contains the 2 replaceable hydrogen atoms. So that means further addition of chlorine can take place, and it will lead to the formation of CHCl3 and HCl. Again it has 1 H atom, so again we can add chlorine and it will lead to the formation of carbon tetrachloride with HCl. So this is something, the chlorination of methane. As I did for methane, you can do it for any alkane, but I took this example because the important property of this example is that it takes place in presence of sunlight. Otherwise the alkanes react at high temperature and high pressure because they have low affinity towards reaction, because somehow they are stable. But this reaction take place in presence of sunlight. Now as you can see, there are so many like the mixtures are obtained, like here is methyl chloride, there is methyl dichloride, methyl trichloride, and here we have this thing, the carbon tetrachloride. But we can separate these mixtures actually because they can be separated by fractional distillation, because they have, or you can say they differ in the boiling points. So by just by this process, that is fractional distillation, we can just separate the components. And you know what is the common name for this compound, CHCl3? It is chloroform. You know that what is the chloroform and what is, for what purpose it is used in hospitals. So this is actually the formula for the chloroform, that is trichloromethane, right? So it is actually the common name which is used is chloroform. Now the second property is that combustion. So what happens when we burn alkanes? So when we burn alkanes, obviously it is formed of an hydrocarbon, so it has no other thing other than C and H. So obviously it is going to produce CO and H2O plus heat and light. So this is how the combustion of the alkane take place. But when we talk about the control oxidation, so you'll be surprised to know that it can form the alcohol, it can form the aldehyde, and moreover it has the ability to form the carboxylic acid as well. So see under what conditions it form. When alkane undergo oxidation, in presence of copper it forms alcohol. And when alkane undergoes oxidation, in presence of molybdenum oxide, it forms an aldehyde. And when alkane undergoes oxidation, in presence of silver oxide, it forms the carboxylic acid. So that means it has a tendency that it can be converted into different functional groups. It is just by the process oxidation. And what is the difference between that? The difference here lies in the use of the catalyst. When the catalyst is copper, it leads to the formation of alcohol. When it is molybdenum oxide, then it is aldehyde. When there is silver oxide, it leads to the formation of carboxylic acid. And the carbon atom is just going to remain same, right? Like if there are the member on left left hand side belongs to the second member, that means the eth one, obviously you are going to get the eth member on the right side. Now, what is pyrolysis? Pyrolysis is also called as cracking. It is actually when we heat alkane in absence of air at high temperature. So, when we heat alkane at high temperature, right, and in absence of air, what do we get? It breaks into, a bigger alkane breaks into lower alkanes. For example, see, here I have pentane. We have high temperature and absence of air. It just breaks into propane and ethane. See, you need to just balance left hand side and right hand side. At this side I have got 5 carbons, so you have to form the alkane this side which contains the 5 carbon, right? And similarly, as I have H12, so here also it comes out to be 12. So that means the number of carbon and hydrogen should be same, right? So whenever you will be just decomposing the higher alkane into the lower alkane, just get to make those lower alkanes which just satisfy the number of carbon and hydrogen present on the left side. Suppose if I just pyrolyze this methane, what I am going to get? So obviously there is no other lower alkane other than CH4. So obviously it is going to just break into its constituents. So if you get to like if somebody asks you to just show the pyrolysis of the lower member, so just break it into the like if it is methane, just broke it into CnH2, because there is no other lower alkane other than CH4. You know that it is the first member. Now when we talk about the slow oxidation, so alkanes also show slow oxidation. How? When alkane undergo oxidation, right, so in presence of K2Cr2O7, it forms alcohol. And alcohols on further, like the reaction doesn't stop till alcohol. When it is oxidized, again it forms the aldehyde. Again, we are just talking of the same catalyst use. When it is undergoing oxidation, then again it shows a slow oxidation, get converted into the carboxylic acid. And when carboxylic acid is further oxidized, you know, it breaks up into CO2 and H2O. As we discussed in the previous lecture as well, that this is something very important in organic chemistry, because you get to have certain questions related to this phenomena. So you should know that when alkane is oxidized, it gets converted into alcohol, and when we just oxidize alcohol, this is the slow oxidation process. It gets converted into aldehyde, aldehyde to carboxylic acid, and when carboxylic acid is further oxidized, they get just break into the the carbon dioxide and the water molecule. And you know, the reverse happens for the case of reduction. That we'll be discussing when we'll be discussing something else, because alkane on reduction doesn't show anything, right, because it is already it has the hydrogen. So that is why I'm not explaining the reduction here, but definitely we'll be doing the reduction when we'll be considering the alcohol aldehyde, or we'll be considering the alkenes or the alkynes, right. So this is what is the chemical properties of the alkane. So this should you have to keep in mind, that they undergo substitution reaction. They do not undergo, in any case they can't undergo the addition reaction. The reason being, they don't have any extra bond, right. So when you are adding chlorine, it is chlorination. When you are adding bromine, it is bromination. When you are adding anything, what we are adding just means it is a kind of, you are not adding it, actually it is just going to substitute the hydrogen atom. So this is what. Combustion again is burning, because it is formed of hydrocarbons. Obviously you are going to get the carbon dioxide and the water molecule. When we talk of the oxidation, so we get different products on oxidation just depending upon the catalyst we use. So you need to remember the catalyst, right. Pyrolysis is the breakdown. This is very easy. You just need to break down the bigger alkane into the lower, and just keep in mind it should satisfy the number of carbon and hydrogen on left and the right side. And this is the slow oxidation process. So this is the chemical properties of the alkanes.